Biology. It's Miss Aninga here. I wanted to come on and help you out with sex-linked genetics. Stuff you've probably never seen before, but I wanted to come on and see if I can't make some sense for you if you're having trouble. So, sex-linked traits are basically traits that are connected to one of our two sex chromosomes. And if you recall from our last unit that we have two types of sex chromosomes. We have the X chromosome and we have the Y chromosome. And if you remember, the sex of a person is based on the combination of your chromosomes that you have. Most normal individuals, like normal females, have XX, two X's, whereas males have an X and a Y. So what this means is for sex-linked stuff is that your trait will be on either the X or the Y chromosome. So when it's passed down, it will be given to either just men or just women, or just males or females, depending on the genetics that they have. So on your sheet, it says that all of your diseases or disorders are sex-linked recessive. This is important because, for instance, it's not talking about an uppercase X or a lowercase x or an uppercase Y and a lowercase y. By recessive, we mean that the trait on that chromosome is recessive or dominant. And so, for example, we have hemophilia, which is represented as an H. It's recessive, so it's a little h, and normal clotting blood is a capital H. So say we had a chromosome, an X chromosome that has the hemophilia trait on it. This would be written as X with a little h because it is a recessive trait. That's why it's a little h. Okay? So that's only one chromosome that has the hemophilia trait on it. If it didn't have that trait on it, it would be a capital H at the top next to that X. Okay? So, for instance, if we go down to number 1 and look at number 1A, it says that we have a female with no family history of hemophilia. So all females, typical females anyway, have two X's, and it says she has no history of hemophilia whatsoever. So this means that she's not going to have a bad X. She's not going to have one that has a hemophilia trait on it. So basically, excuse me, thank you, crackers. So this means that both of her X's will be dominant for the normal blood clotting gene, okay? Because she has no history of it, okay? Whereas if we look at the male here with hemophilia, this is so number 1B, each male, typical male, has an X and a Y, and it says he does have hemophilia. Now, sex-linked recessive disorders are either on the X or the Y. All of these, unless it is specifically stated in our worksheet, are linked on the X chromosome. Okay? So, according to this, he has a small h, and that's all I put because it's only attached on the X chromosome, not on the Y. So the Y doesn't get any sort of indicator on it because we don't need to pay attention to it. In this case, since he has no other X here to cover up this, he has hemophilia. Whereas a female, if she had an affected X, so for example, if I had a female over here that looked like this, she would not have hemophilia because remember, with our dominant recessives, we need to have at least one dominant gene to cover up the recessive. So this female, this one in my example in the box here, has a family history because of this H, but she doesn't have hemophilia. In this case, a female like this is called a carrier. Okay, because they carry the gene, but they don't show it because they have this extra X. Males, on the other hand, aren't lucky like females. So if they have the disorder on their X chromosome, they're kind of stuck with it because they don't have an extra, unless they were the very rare case of an XXY individual. But those are very rare, and so we normally look at genetics like this. Okay? So that's how you would answer for like 1A through G. You just put down the genotypes of your individuals. Let's do number 2 here to see how you would do that. So with number 2, now we're getting into the part where we have to put in your genotypes and like do Punnett squares. So for here, we have to, figure out the genotypes of our male and our female that we have to put. So I'm going to draw my Punnett square, and I'm going to fill it out with mom up here and dad over here. Notice I put Y second. Y is recessive to X, so that's why it goes second. And let's see what we have to write in here. We have a female who is a carrier of the gene of hemophilia. So, like I just talked about over here in my box, a carrier is a woman or a female who has one dominant and one recessive. So, one of our X's up here has nothing, and the has a normal blood clotting gene, and this one has a hemophiliac gene. And then for our male, it says he has normal blood clotting. So he has normal blood clotting on his X, and the Y we leave alone because obviously it's only on the X chromosome. You fill your Punnett square out just like any other Punnett square. So, oops, sorry. So we have X big H and X big H. In that one, we have X big H here, and then X little h. Remember to keep your dominants that come first and your recessives come after. This one is X big H, Y, and X little h, Y. So that's how you fill out your Punnett square, just like normal. And then here in the question, it says, tell the expected phenotypic ratio of the offspring. So all these individuals are your possible offspring. You'll notice we have 2 females and 2 males, just like we normally would. Each time you have a kid or someone has a kid, their chances of having a boy or a girl is 50%. Our phenotypic ratio, though, shows us if they do or don't have the trait. So in this case, we have, females with the trait with hemophilia, females without it, we have then males with it and males without it. Okay, and all we had to do is count them up and label it accordingly. So if we look here, we have this female has 2 capital H's, so this means she's normal. So normal, big H, little h, that carriers. So this individual is a carrier, but they have a capital H, so that means that they're normal. This individual has a capital H and a Y. This means he is normal. And little h on your X, Y, this means that they are affected. So according to what we just looked at, 2 of our females do not have hemophilia. None have it. And on here, we have 1 male that does not have it because of the big H, and 1 with hemophilia. Okay. You do not need to put down that there is 1 carrier, and this is because we don't know that unless we see what her children have. If her children show up with hemophilia down the line, then, like, especially if her boy shows up with it, then we know that she carried that gene. Okay, but that is not a phenotypic trait that we know, that is a genotypic trait. So we don't put it here. Okay, so that's how you do number 2 from start to finish. Let's look at one more, and that's going to be number 7. And I'm going to start it, get you most of the way through it, and then you get to finish it up, okay? So I'm going to draw my Punnett square here. Label mom and dad, and let's read it here. It says, hairy ears are caused by a gene on the Y chromosome. Okay. Every single one we've been dealing with so far has been on the X chromosome, but this one is on the Y chromosome. And since Ys only show up in males, it doesn't matter if they're dominant or recessive, because if a male gets this, regardless, it is that then that individual is affected. Okay, so when doing Y traits, we usually put just it's affected, because it doesn't matter if it's dominant or recessive. Okay, so if you want to put a letter up here, that's perfectly fine. I'm just going to put a little like dashy dash up here to represent that it is affected. Okay, so if we look on here, it says if a male with hairy ears has children, what would be the expected phenotypes of his sons and his daughters? So this means that since it's only on the Y chromosome, if he has hairy ears, it's affected. And then you just fill out your Punnett square just like you normally would. You'll notice I didn't put anything on the X's, and like I said, this is because it's only on the Y chromosome, so the X's don't get affected. So you fill out your Punnett square just like normal. And then you just put down your phenotypic ratios of all your, children that you have. How many females have hairy ears, how many don't, how many men do, and how many men or males don't. Okay, So that one I'll let you finish up. As for on the bottom of your sheet, you have 3 questions. Try answering those as best as you can. I talked about what a sex-linked trait is at the beginning of the video. If you need to go back, you can look at that. Whereas 9 and 10, you have to think about it and give me your best answer. Okay? So, good luck on that. You can do this either by hand like I did it or on your Google Sheet. I know you can type in your boxes. So do either of those for me. And if you have questions, let me know, okay? All right, biology, I'll see you later. Bye.